All right, you guys, today we're looking at just-in-time 10.4 and 2.1. All right, so it's 10.4, we're looking at the factor theorem and long division. So the factor theorem is this theorem, and it's a theorem is just a statement that has been proven true in really simplistic terms. But so the factor theorem, if we have p of x to be any polynomial, okay, and x be any real number, then x minus a is a factor of p of x if and only if p of a equals 0. If p of a equals 0. So we'll see this. So problems will often be worded like show one is a factor of this and then factor completely. Or is this a factor? Okay, so for this we'll say, okay, well, what is p of 1? So p of 1 is equal to, I'll plug 1 in for our polynomial up here. So it'll be 1 cubed minus 2, 1 squared minus 5, 1 plus 6. So 1 minus 2 minus 5 plus 6, which should equal 0. Okay, so x minus 1 is a factor of our polynomial. Okay, so now we'll factor it completely. So factoring completely, we'll use polynomial long division. So we'll do x minus 1 divided, or we'll do x minus 1 divides our polynomial up there, or this polynomial is divided by x minus 1. Okay. All right, so when you're doing polynomial long division, you're going to want to look at the x value primarily. Okay, so we can see that x minus 1 goes into these first two terms, x squared times. So I'll do x squared times x minus 1, which gives me x cubed minus x squared. Okay, and I subtract that from x cubed minus 2x squared, which gives me a negative x squared. Okay, then I'll bring down my negative 5x over here. So then I look at, okay, well, how many times does this x minus 1 go into negative x squared minus 5x? And that would be negative x times. So negative x times x minus 1 will be negative x squared plus x. All right, subtract that away. I'm left with negative 6. I bring down this 6 to plus 6. And then we say, okay, well, x minus 1 goes into, wait a minute, you guys. This should be negative 6x plus the 6 I brought down. Okay. All right, well, so we'll notice that x minus 1 goes into negative 6x plus 6, negative 6 times. So negative 6 times x minus 1 will be negative 6x plus 6, and I subtract that away and gives me 0. So that means that my polynomial, so p of x, so x cubed minus 2x squared minus 5x plus 6 factors into x minus 1 times x squared minus x minus 6 from over here. Now, this is not factored completely, though, because I can still factor this. Okay, so factoring completely, it'll give me x minus 1 times x minus 3 times x plus 2. Okay. And then our one other factoring method that we didn't talk about yet, and we'll talk about it more later when we talk about quadratics, but there is a quadratic formula that we can use for our polynomials. And so an example with it real quick will just be, we have our polynomial here. We can plug in our numbers. So we have negative b, b is 1, plus or minus the square root of b squared, so 1 squared minus 4a is 1, c is also 1, all over 2a, which is also 1. Okay, so we simplify and we get it down, and we've got a negative 3 under that radical. So what that means is that there are no real roots. Okay. And when we get into, in just a few videos, we'll talk about what to do with negative 1 under there. But for right now, just know that that is one more factoring method that you can use. Okay, so our last factoring method we'll talk about is completing the square. So completing the square uses this formula. Okay, well, completing the square uses this formula. So if I have a polynomial, okay, then I can take, and if there's an a term, I'll factor it out, and then I'll add in that b over 2a, and well, you're left with b over 2a, and you add on this term here. Okay, but this also gives you the transformation formula, or not formula, but if we're given this way, it's easy to see we've got this horizontal shift here, and a vertical shift here of the graph x squared. Okay, this formula just is really easy to read that from once we use this method. But what completing the square is doing really is, so if we're given a square, okay, and let's say that this side is a length and this side is a length because it's a square, and then we've got this piece over here of length b. Okay, and what we're doing is, if we take this and we split this b, we can also use this to rearrange the terms so that way we've got a square. So our square okay, so we've got our square of length x, and then we've taken this b and split it in half and dragged one of them to the top to make it a square. So this is of length b over 2, b over 2. And what we're looking for in completing the square is this piece over here. Okay, that's what we're really doing when we're completing this square. Just so you know. All right, so we'll do some examples with completing the square. So an example would be, like if I've got this polynomial, okay, my a value is just 1 here. Okay, so I'll take and I'll add on so if I've got x squared minus 3x plus, and I'll add on 3 over 2 squared, and also subtract it away. And then plus the original 4. So what I did I'll zoom out a little bit so you can see both. Okay, so in red, what I have here is what I'm adding in to both of these. Okay, or adding and subtracting. Okay. So what that gives us is x minus 3 over 2 squared plus 7 over 4. Okay. Now you can also, sometimes when you're completing the square, you're given completing the square problems, it'll be really asking you about a circle. So our equation of a circle centered at HK with the radius R is given by this formula. Okay, so when it's given by this formula, or the way these questions will be worded is they'll give you something and they'll say, what is this circle centered, where is this circle, complete the square to find the radius and center of the circle, something like that. Okay, so in this case, you'll have to complete the square twice, once for the x terms and once for the y terms. Okay, so we'll do the x terms first. So I've got x squared minus 2x plus 1, because that's 1/2. 1 comes from 1/2 of negative 2 squared. Okay, and that should be a plus 1. All right, so there's my first completing the square, and then our second, so plus y squared plus 2y. And then again, so we've got 1/2 times 2 from that b term squared, which gives us a positive 1. And then we also have to subtract those terms away on the outside. Alternatively, you could add them to the other side over here too, but it's whichever way is easier for you. But so then we can simplify, and so we know that this will be, we've got x squared minus 2x plus 1 plus y squared plus 2y plus 1 is equal to 4. This 4 comes from adding these over here. All right, and so then we can factor, so we get x minus 1 squared plus y plus 1 squared is equal to 2 squared. So then we can see this is a circle. Centered at 1, negative 1 with radius 2. All right, so yeah, a lot of times when you see completing the square questions, they will be in terms of this circle. Okay, you might see them other ways, but a lot of the times they'll be with the circle. All right, if you've got questions, you can ask me in class or email me.